All right, example number 5 says, for the circuit shown above, find the equivalent resistance. That's part A. Part B says, find the power dissipated in the circuit. Part C says, find the current and the voltage for each resistor. And then part D says, find the voltages from A to D, that's from here to here. And then from B to C, from there to there. All right. And the only kind of tricky part is going to be the power dissipated in the circuit, and we're going to have to go back through a couple of the other things that we looked at before on that. But by and large, for the rest of this, it's going to be a breeze as long as we remember what we know. Okay. So let's take a deep breath and go ahead and start this. If we want to find the equivalent resistance, we have to look at what parts are in series and what parts are in parallel with each other. And when I'm looking at this, what I know is any electron that comes out of here has to go through this part, but at this point it's going to split. All right, so my current is going to go that way, and then I'm going to get some of it this way and some of it that way. All right, and then I know that this is going to come down here, that's going to come all the way through here, and then they're going to combine. I'm going to get the current going back into the battery down there. All right. So if I redraw this, I can redraw it. And I'm just going to do a rough sketch. I'm not going to do the whole whatever, but I can redraw it like this. Right? This is the same circuit as that, where that's the 15 ohm resistor. This would be the 20 ohm resistor. This would be the 10 ohm resistor, and that would be the 50 ohm resistor. I'm not labeling these with my units just because I want you guys to associate with that, but I don't want to go too far in depth here. But I do want you guys to note that my current essentially comes through here. It splits between these two legs, and then it's going to come back together and then go through the 15 ohm resistor and then come back to the battery. All right. My 10 and my 50 ohm resistor in this part are in series with each other. Okay. So if I get a different color here, right, and I circle these, the resistance of this part is actually going to be 60 ohms, right? So it's 50 ohms and 10 ohms, and we know that for two resistors in series, then the total resistance of this part of the circuit is a combination of those, or a summation. You add them up, you get 60 ohms, right? Now then, for the next part, what I want to do is find the resistance of that part, right? Well, if I have a 60 ohm resistor in parallel with a 20 ohm resistor, for this one, my resistance is 60 to the negative 1 plus 20 to the negative 1 to the negative 1. And I'm not 100% sure what that's going to be, but I'm going to calculate that out here. And I get 60 to the negative 1 plus 20 to the negative 1 to the negative 1, and it gives me 15. So the resistance of this box is 15 ohms, right? So if I were to replace this giant chunk of circuit here with something else, it would give me a 15 ohm resistor. So this part, this whole thing is in series with this. That doesn't mean that this one is in series with that one or that one is in series. These ones are in series with each other, but they are in parallel together with this one. Okay, and this part of the circuit is in series with that. So 15 ohms in here plus 15 ohms gives me 30 ohms. So my total resistance is 30 ohms. All right. My equivalent resistance, RT, is 30 ohms. So if I want to know the current coming out of the battery, I'm going to say I is equal to, I times R is equal to V, so 90 volts equals I times 30 ohms, which means my current coming out of the battery is 3 amps. All right. Now we want to know the power dissipated in the circuit. We know that power equals voltage, not velocity, times current, right? We have the voltage. Yes, it's 90 volts, so 90 volts times I is 3 amps, which means that I'm going to multiply 90 by 3 to get 270 watts. So that is a 270 watt circuit, okay? So that is the power being dissipated by the circuit. Part C says find the current and the voltage for each resistor. This is where it gets kind of, I'm going to say, fun, okay? We know that the current across here, coming through here, is 3 amps. We know that that has to be the same current here, and that has to be the same current here. If I have 3 amps coming this way, I must also have 3 amps coming this way, right? Again, that's a specific amount of electrons per time. So if I know that, now I'm going to go ahead and put 3 amps. If I want to know the voltage dropped across here, I'm going to say 15 times 3 is 45 volts. All right. Now then, if I look at the loop rule, I know that the voltage to here from here must be 0. And by that, I mean I don't care if I go this way or if I go this way, right? And I'll talk about going this way in a second. But if I know that my current through each of these is like this. So it's forming a little circle in here, right? So I know that my voltage must be positive from here to here, okay? So if my voltage from here to here is negative, positive, positive, that means I'm going to be able to find this one, right? Actually, from A to B is negative because I'm dropping voltage here. I'm gaining voltage across the battery. So I have a higher voltage here, a higher electric potential at this point than at this point. So I'm getting higher voltage from here to here, and then I'm dropping voltage here, dropping voltage here. I've dropped 45 volts here. So if I have minus 45 plus 90 plus some unknown number is equal to 0, then that unknown number must be equal to negative 45. Okay? My voltage dropped across here is 45 volts. I'm going to pause this and then continue this in a separate one.